Hi class, today we are going to get going on 7.2, which is talking about how to expand and condense different logarithmic equations. So there are some different rules that we're going to learn that we use to expand and also to condense, which I will show you what that means in a second. And then we're also going to look at how to use a calculator a little bit more when we use logarithms. So here are the rules we're going to be using. You might want to pause the video right here and write all of these different notes down really quick so you have them for your homework. But the product rule, remember in math, product means the answer of a multiplication problem, so we're talking about multiplying here. In logarithms, when we're looking at the inside of the log, if two different terms are being multiplied inside that log, what the product rule says that we can do is we can break this up into two separate logs. So now I just have the log of x and the log of y, and we break them apart by adding them together. They will have the same base on the log still, so see that this log base b is still the same on both of them, but instead of having them together, which we call condensed form, we can expand them into two separate logarithms. And then same with the natural log. Remember, we have these little ln's, which stand for the natural log. If I have x times y on the inside, I can break that into two new natural logs so that I have the natural log of x, and then I add the natural log of y. So that is when we are multiplying on the insides. The quotient rule, remember quotient is for division. It's going to be pretty much the same thing except when we are dividing the inside. So here I have x divided by y. We can break that up into a log base b of x, and this time we're going to subtract log base b of y. So they're each getting their own logarithm, and instead of dividing, we're going to subtract the two. So this would be the condensed format, and this is the expanded format. And then this would be the natural log version. We have the ln of x divided by y is the same as the natural log of x minus the natural log of y. And then the last rule is called the power rule. This is going to have to do with exponents or powers. So what this says is if on the inside of your logarithm, if it's being raised to an exponent, another way we can write this is we can take this exponent and bring it to the front of the logarithm. So now we have the c in the front. So it's like I had c here, but I'm just bringing it out to the front. So whenever you see a power, we can use that and bring it in front. And then same with the natural logs. If we have the exponent here, I can think of bringing this exponent to the front and write it as c times the natural log of x. And these different rules come in handy when you are solving logarithmic equations. Right now they might seem kind of weird, but you'll see how we use them and how they can make it a lot easier to do different problems, especially when you get into calculus and you're trying to do derivatives or integrals and you have something more complicated like this. You can break it up into a simpler format by expanding it. So these rules come in handy a lot when you move on in math. So we're just going to practice using these rules. So for the first set of problems, we are going to practice expanding. So right now, all of these problems are in condensed format. That means all of the terms are inside one logarithm. We want to expand them so that they each have their own logarithm using the product rule, quotient rule, and exponent or power rule. So on this first problem, let me zoom in a little bit. We have log, and then remember if there's no base, it's a base 10. We just don't write base 10s. And then on the inside, and you could put this in parentheses if you wanted to, we have a to the fourth times b divided by c to the fifth. So right now in the numerator, these two things are being multiplied. So we are going to use that product rule on these ones. And then this is being divided, so that's going to be using the quotient rule. So when you have a fraction, anything in the numerator is going to be using the product rule, so we're going to break them up by addition. And then anything that's in the denominator will be subtracted using that quotient rule. So think of each of these different terms getting their own logarithm. And it is a base 10, which I don't need to write. So I'm going to have a to the fourth, but then it's being multiplied by b. So I'm going to add it whenever it has a multiplication. And this b is now going to have its own log. But then since c to the 5th was being divided, we're going to subtract it down on the bottom, and it gets its own log as well. So we did the product rule with the a and the b, and then the quotient rule to subtract the denominator. And then we have one more step because we have these exponents right here. So we can use that power rule that's going to bring those exponents down into the front. So this 4 is going to come down in front. So you have 4 log of a. B doesn't have an exponent, so we can just keep log of b. And then this 5, think of bringing this down in front. And then that would be your answer. So this would be expanded version. So here's the expanded version of this logarithm. Condensed format, expanded format. Okay, let's look at another one. This one we see is a little bit different already because it has that square root over it. So when you come across roots, either square roots, cube roots, etc., remember that roots can be written as an exponent. So if I have like the square root of x, that's the same as x to the power of 1/2. Or if I have a cube root of x, that's the same as x to the 1/3. So you'll want to remember that for this section, because whenever we run into roots, we are going to want to convert them into their exponent format. So since this is a square root, this is technically the same as the natural log of m cubed n to the power of 1/2. And then because we do have different terms in here, this square root, it does cover both the m and the n. So I need to remember that this power is really going to both of those terms. They are also being multiplied. So when I want to break these apart, we want to use that product rule. So they're each going to get that natural log. I'll have m cubed, but then because this is a cube and to a power of 1/2, remember when we have a power raised to another power, you times them together. So 3 times 1/2 would be 3/2. And then now we're going to add to it the natural log of n, but then the 1/2's also applying to the n. So it also gets a half on there. So the product rule is breaking it up with an addition sign. And then now we have to do that power rule to bring these powers down into the front of the natural log. So I have 3/2 times the natural log of m plus 1/2 times the natural log of n. And that would be your answer there. Okay, and then this one, so kind of a messy looking one. We have a lot going on here. When you're doing these logarithms, a tricky thing that a lot of students forget is numbers. If I have like a coefficient in front of a variable, they count as their own base. So I'm going to write that here. This counts as a base. So it gets its own log. It's not attached to the w. So when I split these up, I really have 3 things on here. I have a 2, I have a w, and I have an h. They're all going to get their own logarithm. And then on the denominator, I have an a and a b here. So anything in the numerator, we're going to break up as a product rule. So we're going to do a log of 2 plus a log of w plus a log of h. Anything in the denominator is going to be subtracted. Even though these are being multiplied, the a and the b are both being timesed on the bottom, because they're both in the denominator, we're going to use that quotient rule and we're going to actually subtract both of them to show that they are in the denominator there. So this one's going to be a long one because we have 1, 2, 3, 4, 5 terms that we're breaking up. So I'm going to have log of 2. Remember, the 2 gets its own log. And then now I'm going to add to it log of w to the 4th plus log of h cubed for the top. And then these are both in the denominator, so we're going to subtract them. So hopefully I can fit this all on here. We have log of a squared, and then minus log of b to the 5th. And then a lot of you can probably do all of this in one step. You don't need to write this middle step if you don't want to. I know a lot of you probably will just want to bring these exponents down all in one big swoop, which you can. So if you want to do all this in one step, go for it, but I'm going to write everything out. So you have log of 2, and then I'm going to bring this 4 down. So I have 4 log w plus 3, bring that down in front, log h, minus, bring the 2 down in front, 2 log a, bring the 5 down, minus 5 log b. Barely fit that on there. And that would be your expanded form, which makes sense, right? This is all condensed into one log, and here we've expanded it out. It's a lot longer. So that is expanding. Now we're going to reverse it. So we're going to start an expanded format, and I want to condense them. So here we have 2 natural logs on this example. If I'm going to condense it, that means I need to have everything down into one logarithm. I should only have one log in my answer. And you see right here, they're being subtracted. That's going to mean it's the quotient rule. So whatever comes first is going to be in the numerator. Whatever comes second is going to be in the denominator. Another different thing about this one is we have multiple terms inside the logarithm. But notice how these are not being multiplied, they're being added and subtracted. I have an x plus 1 and an x minus 2, versus when we were looking up here, everything was being multiplied. So when you come across groups like this that are being added or subtracted, they have to stay a group. We can't split them up. So think of this as being one group in parentheses. This whole thing is going to go onto the top of the fraction, and this whole thing is going to go into the bottom of the fraction. And then if you want, you can put parentheses around it, and it's going into one natural log. Since we're condensing it, there should only be one of these. And then the other thing we had was this 3. This 3, since it's in the front, if I think about reversing that product rule, is going to come up and be an exponent. But it's only an exponent on the x minus 2. So this little group right here needs to be cubed. So this minus sign showed that we are going to be dividing, and then we had this 3 out front that if I reverse it becomes an exponent for our power rule. And then this would be your condensed answer. So just make sure when you're going from expanded to condensed format, you should only have one log or one natural log in your answer. Let's look at another one. So here I have 3 logarithms that are all going to go into one log at the end. Remember, I should have just one log. And then if you want, you can go ahead and do that product rule or power rule first. This 4 is going to become a power. This 2/3 is going to become a power. And then whatever is being added is going to go in the numerator, and whatever is being subtracted is going to go in the denominator. And if you want, you can put a big parenthesis around it, but we're going to have a 3 times an a to the 4th. Since they're being added, that's going to turn into a multiplication. And then whatever is being subtracted goes into the bottom. So we have b to the 2/3. So again, that power comes up when we condense it. Sometimes they'll be okay with you leaving an exponent as a fraction, but remember these fraction exponents are a sign that it's a type of a root. So a 2/3 means that it has a cube root that's also being squared. So another way you could write this would be log, and then we have 3a to the 4th still on top, but 2/3 is the same as saying I have b squared with a cube root on it. So that's another way you can write that one. So depending on the directions on Math Excel, if they tell you to write your answer using radicals, that means they want the actual cube root in it. If they don't say that, you could probably get away with leaving it in fraction format, but kind of keep an eye out for that sometimes they'll want you to convert that fraction or rational exponent into the root format. Okay, one more of these. Okay, so we have 1, 2, 3, 4 natural logs. We're condensing it. Remember, it needs to condense into just one natural log. Here I have a subtraction, and then a plus, and then a subtraction. It doesn't really matter the order here, but whatever is positive or being added is still going to go up to the top. Whatever is being subtracted is going to go to the denominator. And then I do like to do that power rule first, where we reverse it and bring any of these numbers in the front up to an exponent. So I'm going to go ahead and do that first. And then again, we do see this as a group where they're being added or subtracted. We got to keep them together. So think of that as one group, a d plus 1. And then we can put our big parentheses if you want. And then there's our fraction. So again, anything positive, so the a and the c both have a positive natural log, are going to go to the top. Anything that's negative is going to go to the bottom. So a to the fourth comes up to the top. This one's negative, the b cubed. Let me bring that 3 up. That goes to the denominator. Now this one's positive, so c to the 7th goes to the top. This one's negative, and we need to take this whole group. So think of this as being in parentheses d plus 1, and then that entire group is being to the power of 5. So that would be your condensed format, and you're done. And that would be your answer. We don't have any roots in that one that we need to fix, so we're good. So that is going from expanded form into condensed format. Okay, and then the last thing we're going to look today is evaluating some of these logarithms, either using a change of base formula or using your calculator. So most calculators only have a log and natural log. Remember, if it doesn't have the base on the button, that means it's a log base 10. So this is a log base 10. So what happens if you need to do like a log base 2 or a log base 5? This change of base formula allows you to do that using just a log base 10. So if I have a log with a different base number other than 10, I can write it this way using the log base 10. So I would do log base b of x is the same as log of x. So I'm taking this goes to the top, and the log b goes to the bottom. So if I don't have a fancy calculator, you can do it this way, which I think your phones, if you are just using your phone calculator, you can use this change of base formula instead. I actually sometimes prefer to do this anyways, even if I do have my graphing calculator, just because it's a lot faster than trying to go and get the log button that allows you to do the base. So if you remember that I showed you last time, in order to do a log with a different base, you have to go to math, and then you have to scroll all the way down to this log base button, and then it allows you to type it in. So let's just say I want to do log base 2 of 5, and I could type that in. Sometimes I still think it's quicker just to do this log button. So like I could do the log button, which means it's a log base 10, of 5 divided by log base 2, and I'm going to get the same answer. So I almost sometimes think it's quicker to do this because I don't have to go into that math menu to get this special function. I can just type it out using the log button right there. So it just depends on how you want to do it. And it works the same way with natural logs, actually. If you do log base b of x, I can also write it as just the natural log of x divided by the natural log of the base. And that natural log button is just underneath the log button next to the number 4 on your calculator. But we can look at a couple of these. So if I have a natural log of 7 on this one, we have the button for that on our calculator, so we can just type that in, natural log of 7. We get this. They should tell you what to round to. We'll just do 2 decimals, 1.95. On this one, again, it's a base 10, so that one's okay. We can just go straight into our calculator, log of 0.15, and we get a negative 0.82. But then on these 2 problems, we see we have different bases. So let's pretend I can't do this in my calculator with that fancy log base function. I can use my regular log base 10 button by just doing log 17 divided by log 4. And I kind of remember the order just by thinking of this as being the fraction. 17 goes to the top, 4 goes to the bottom. It already kind of looks that way. So if I just type that in, if I do log 17 divided by log 4, we get this answer, 2.04. And then again, we can do it with this one. It'd be the same as doing log of 26 over log of 52. And I can just use the regular log button rather than trying to get a fancy base. So log of 26 divided by log of 52. And we get 0.82. That's our answer. So there you have it. So if you don't have a fancy calculator, you can always just use your regular log button by just splitting up the inside and the base So the inside goes to the top, the base goes to the bottom. And that is it. So your homework's just on Math Excel. As always, feel free to email me if you guys have any questions, and I hope you are all safe and healthy, having a good week.